Hi, and welcome to another episode of Conversations with Dez. Today I have the honor and privilege of having a guest from IBM. My guest today is Marcel Mitran. Marcel, welcome to the show.
Hey, thanks for having me, Des.
Thanks for staying up. Now, I understand it's probably about 10 or 11 o'clock at your end in sunny old Toronto, so I appreciate you burning the candle at both ends. In my case, it's a beautiful sunny morning at about 11 o'clock, and I'm staring at lovely cloudy sky out my window. So thanks for staying up late. Really appreciate it.
I'm excited to be here, man. This is going to be fun.
It is indeed. So just to quickly introduce you, and then I'm going to get you to probably do a far better job yourself. But Marcel, you're the CTO of IBM LinuxONE. You're a distinguished engineer at IBM Systems. And I was looking at your background just to get some insight into you personally. And it looks to me that you spent about the last 20 years developing both hardware and software technologies, specifically to solve problems around sort of modern enterprise challenges. But correct me if I'm wrong, but I think you've spent the last 16 of those years at IBM in various roles, culminating in your current role as CTO for LinuxONE. Is that right?
Yeah, absolutely. Yes. I've been with IBM for 16 years, started off as an entry-level compiler developer, and just kept getting more and more excited about the stack and learning more and having more influence over a broader part of the stack, and that somehow turned into a role as CTO for this exciting Linux platform.
And I understand today you've got some pretty exciting news to share as far as big announcements go. So I'm very keen to lead into that. We've seen a number of things come out the last few days around the press and the media. But perhaps I could just throw to you to maybe just share this exciting announcement, and we can kind of lead into a few questions around it.
Sure. Yeah. We were at Open Source Summit and announced the availability of the LinuxONE Emperor II, which is the second generation of our enterprise Linux server systems. I mean, these are just amazing systems that are really designed to meet the needs of the modern enterprise, and bring to bear all the exciting capabilities of the Linux ecosystem.
It's an interesting shift to when people think about IBM and they think about sort of the traditional sort of big iron that IBM's been involved in for essentially 6 decades now, since the very first big iron machine that was being built, but the last, I guess, 40 to 50 years of mainframe, and particularly the current edition of sort of the CMOS-based platforms. I often have people sort of look at me and sort of sit up and think, Linux, open source, IBM, really? But this is a fairly natural thing in my mind, the transition sort of for if we shake off the legacy view that mainframe is an old platform. I remember having a conversation with Steve Dickens inside the IBM team, and he had this great line that I'm going to share here. He commented that around about 1967, the Porsche 911 was released as a car around the same time as the sort of the latest edition of sort of the mainframe architecture in many ways. And he said, when people think about the new Porsche 911 2017 edition, they don't tend to look at it and expect that it's going to have the 1967 brake systems and steering column, right? And yet for some people, they look at it and think that IBM's mainframe platform hasn't really shifted in that many years. But that's very much not the case at all, is it?
No, this platform has been evolving at an incredible pace, keeping up with the needs of modern business and modern computing and modern enterprise. We've got industry-leading Java on the platform. We run a huge open source ecosystem, everything Docker, Mongo. You'd be amazed at just how rich the platform is and how capable it is and how much it's evolved over those 60 odd years. And Linux, we've had Linux on this platform for, over 16 years now. We were there in the early days, in the late 90s with Linux on the mainframe. So with LinuxONE, what we really did was we took it to the next level and decided to go full out and build Linux-only systems to meet the needs of, our modern enterprise and customers who have a need for Linux, but Linux with high availability, high security, scalability, and resilience. So, yeah, you're right. This is a very modern, very capable, a very exciting system for Linux.
When we think about the history of Linux, just as a side, I think it was about 1991. Originally, the very first sort of announcement came out with regard to Linux as a thing. I remembered, and there was early editions of all kinds of things. There was one called Yggdrasil that I think was my very first Linux platform that actually booted. But when we think about that timeline, if it was roughly, let's say, what's that, 1991, 26 years ago, Linux became a thing. As you just said, I mean, for the better part of, well, let's say 16 years on your platform, that for the bulk of that modern duration of the life of the Linux kernel and the ecosystem around it, it's been native on the mainframe platform. And when I think people think about mainframe, they often sort of think about old 3270 terminals and these clanky old operating systems. But Linux effectively powers everything these days. It's in my damn phones, it's in our cars, it's the cloud. So it's interesting that I think there's a lot of people who are surprised when they hear this, and yet to me, I sort of think, well, it shouldn't be a surprise that Linux made its way onto the mainframe and that it made its way there as a native client as opposed to just something sitting in a virtual machine. And it seems to me that it's a natural progression, that it scales well. I mean, we see it scaling well in the cloud. We see it scaling well on mobility devices. Given that the modern mainframe is a ridiculously powerful workhorse, it seemed a natural transition for Linux to be there. If I would love to delve just quickly into when we think about the design of the system, when we think about the heritage of sort of what we've seen over the last 50 years. When we think about the current edition of the Z14 with security baked into the DNA of the hardware and security baked into the DNA of the latest edition of LinuxONE, are there any key insights that you could sort of share around some of the influence that sort of came into the modern enterprise platform that you sort of gleaned from the last 50 years? What sort of things have you been able to leverage and learn from over the last sort of 5-odd decades of IBM's hardware platform and operating system design that have made their way into LinuxONE?
Oh, there's so much. I mean, to start off, I mean, the system from a security perspective, has hardware security modules, HSMs, built into it and integrated that are, FIPS 140-2 level 4, and that, that's the highest certified HSM you can get in the industry, and that's a design point, that's inherited from that, the need in that legacy enterprise space where, you've got data that's powering the modern economy, and that, obviously is incredibly sensitive. So you have to, operate at that level of security. Those HSMs are probably, one example. The systems are actually, with one of the other key sort of design points that you have to think about when you talk about enterprise computing and enterprise data serving is they're inherently scale up in that, when you're serving data that runs a large enterprise that can never go down, you have to be able to non-disruptively grow and manage that data serving environment. And so these boxes are designed for scale up. They're designed to grow vertically and do so in a completely non-intrusive way. So you can add resources to these Linux environments. You can add CPU, memory, I/O, and you can do that without ever having to bring the system down. And in a similar fashion, you can add Linux environments to it non-disruptively as your need for more transaction processing, application serving grows. And so you get this really unique sort of topology where you can grow your data serving environment vertically or scaling it up, and you can grow your application serving environment horizontally by scaling it out. And you can do this all in the context of a single system where you have 85 different hypervisors running, and each with its own set of Linux environments, and all of these hypervisors you can manage the resources underneath them transparently, and you can build this really efficient communication channel between the different environments, because when you're on a single footprint, a socket or a TCP/IP stack is essentially a memory copy under the covers. So you have this wonderfully elastic system that can do some amazing things and solve some problems that you just can't solve elsewhere with other platforms.
It's interesting that when, I'm going to be upfront and honest here, people are going to think that I'm old, but, at the age of 14, I used to escape from school early. I used to forge my mum's signature, which I've disclosed to her many times now. And, my school teachers probably thought I had the biggest dental issue and psychological issue you could ever imagine, because I had to make up these excuses. Dez has got to go to the dentist, or Dez has got to go to an analyst. But I used to sign myself out of school and dash down to a company called Datacom, who had a data center at the end of the road, and I would work as a mainframe operator, putting paper in 132 column printers and tapes and tape drives and run batch jobs. And a lot of what you're talking about now, I mean, some of that stuff was there in the early days and has been part of the design pattern or the design principles in the mainframe from the early days, which is I think in many ways when we look at cloud and we look at a lot of what we're doing with cloud, it's high performance computing in mainframe done in a different way. But we've circled back now, I think, in many ways that people are now saying, well, it's great that we can do it by taking a lot of x86 boxes and gluing them together. But hey, look, there's a platform that's been around for a long time that's just as modern, if not more, and it's all in one platform. And as you said, they scale out. I mean, there's some key challenges around sorts of things that enterprise organizations are of any form, whether it's specific verticals like health and hospitals and aged care or education and children, through to banking, wealth management, and finance, and everything in between, where security and speed and scalability and other key things are not just niceties. I mean, they're necessities, aren't they? These are things you have to assume are there by default. You can't really bake them in afterwards, can you? They're not really an afterthought.
No, you can't afford to lose your banking information, for any period of time, right? You as a banking customer expect to be able to get to your bank account any time of day, and what's more important is if you update that, the information in your bank account, you expect that to happen immediately. You don't expect eventual consistency. you need immediate consistency, right? And that's a hard problem to solve when you start to think about distributed computing and some of the challenges of cohesive data management and partitioned data systems. So, yeah, I mean, these systems are, their heritage is very real, and it was the way they've been built and designed and engineered over 60 years. There's some reality and some very strong business needs that they've been built to meet and have evolved to meet over the years. So, yeah, it is a different flavor of computing capability.
And I think there's a wake up call in many ways for a lot of the we call them cloud natives in many ways, but we see the Facebooks and the Ubers of the world come along, and I sort of refer to them. It's actually a phrase that came out of IBM, I believe. I remember reading a while back. But this idea of a cloud native, an organization who is young enough to not have had any experience other than cloud platforms and mobility platforms, and in many ways they're relearning the things or the lessons that the likes of long-term clients of IBM and others have already known. When you look at, it's exciting to think about booking a car to come around the corner and pick you up via a mobile phone app. But as you said, when you think about some of the I always look at it from the point of view of humanities. I was lucky enough to be at the World of Watson event recently in Las Vegas, and even more recently the IBM Interconnect event. And Ginny Rometty does these great talks for roughly 2 hours, which is a long time to hold people's attention, but she just blows me away. And each time I came away from this thing thinking, this person just spent 2 hours keeping me enthralled and engaged and didn't once talk about technology, talked about the humanities and all of the things that underpin it. And it always kind of, I walk away each time thinking, God, I just keep remembering this. And I looked, before we caught up today, I looked at some of the things that, what happens to me every day? What do I build my life around? And I realized that there's some key things that just have to be stable, that the platforms you're building here with, well, not just LinuxONE, but the IBM platform in general, that make my life possible, whether it's banking or wealth management or insurance or airlines and booking flights, whether it's my state government around me or my federal government protecting the country or just general retail and manufacturing, One of our kids had a health challenge the other day, nothing major, but again, we rocked up to a hospital and things just worked. Whether it's protecting the borders of the country, there's all kinds of interesting things happening around the planet now, and Australia is one of the biggest islands on the planet. So, we've got a key challenge here with, as you do in the US and Canada with your borders. So there's defense, there's transport and logistics and telecommunications. And I started this list thinking, these are really big things that we wake up every day. We jump out of bed and we assume that are good. And many people have tried to put them into, cloud-based tools in many ways, and they haven't always worked well. I can't always get my Skype call to work, but I can definitely pick up my landline and make a phone call. And I'm sure a lot of these little issues will be ironed out, but I think many people forget that under the hood, under the covers, if you like, when you open the kimono, there's some really big iron driving some of these key things around banking, wealth management, finance, aviation, airlines, etc. In fact, so I actually went and did some homework on it just to go on that point. It turns out I looked at who still uses mainframes and who's using some of the platforms you're building. And here's a bit of a brain dump quickly. Turns out 70% of enterprise data still sits on your platforms and mainframes, and I'm sure invariably now on the LinuxONE platform. 71% of the Fortune 500s in the US, their core system's still in mainframe. 92 out of the top 100 banks in the world still run their banking systems in mainframe. 23 out of the 25 top retailers in the world use your platforms. 10 out of 10 of the top insurers on the planet run their entire cloud services on mainframe, and I'm sure on LinuxONE. And two last quick ones. It turned out the top 225 state and local governments in the world rely on mainframe platforms, and effectively all major nations on the planet run their defense systems still on mainframe. So, when I look at that, it's like, wow, I bet if I stood up in a boardroom somewhere and said that to the average company, they would roll their eyes back going, well, you know what? You're right, we forgot this thing. When we think about all of those platforms, I'd love to jump into a couple of key things around security, speed, and scalability in particular, because I think these are three standout areas that would be of interest that you've got some key insights into. When we think about security and how LinuxONE and the mainframe platform from IBM play into this, I think it's fair to say that two or three of the key challenges are things like insider threats, just keeping the general data and the keys that protect that data safe, avoiding data loss. We hear a lot about hacking, but invariably, I think a lot of the data breaches we're seeing now are not necessarily somebody hacking a system, but a system's design just being poorly thought out, and essentially the back door's left open and stuff just leaks. I'd love to get some insight into what you've done around the design and architecture and some of the key strengths of LinuxONE Emperor V2, specifically in this space of security and some of those key challenges, if you could.
Yeah, I mean, one of the key features in the Emperor II that we announced was something called secure service containers. And what those are essentially a pervasively encrypted environment for running Docker workloads, of all things. So what happens is the workloads are, completely encrypted. They're tamper resistant, both at install and runtime. They lock out privileged users to protect against, that insider threat. And so they really do offer, a very secure and confidential cloud computing environment. And we've actually had this technology now for a while. We announced it in Emperor II because we're making it more generally available for others to use. But for over a year now, we've had the IBM blockchain solution in the IBM cloud running on top of inside these secure service containers, right? And you can envision or imagine why a blockchain technology would be would really benefit from that type of security and protection and privacy, and that's really made a huge difference in the success we've had with that blockchain offering. The fact that we could offer that differentiated confidential computing environment really has been a key part of the success and our ability to really get out there and succeed with our blockchain technology.
I think a lot of companies are struggling to come to grips with just the concepts around things like distributed ledgers and what blockchain means. And we get very distracted with sort of what Bitcoin and cyber currencies are all about. And I often, when I talk about blockchain, I often take the Bitcoin concept out and just say, think about it as a secure token. We buy tickets online and we get QR codes sent to our phone via SMS, and we scan that to get into the show. Or we buy an airline ticket and we get a boarding pass and it's got a QR code. And I often look and say, well, that's a secure digital token, and it's often a one-time use or whatever the case may be. And then I link them back to blockchain and what it actually means. And the first challenge that comes up, people say, well, where are we going to get this? And that's when I started looking at, well, there's companies that already do this. It's part of their platform. And I think it's fair to say that, as you've just said, that when we look at what you're doing around not just the hardware stack with the Z14 that's just come out and Linux Emperor II, but you're actually baking in this capability into the platform so that by default, by rolling this out, this is almost a capability that we can assume is there from day one. One of the things that I was really interested in reading around when the sort of Emperor II came out, having been a developer for too long and then moving out of coding and just moving into business challenges, I'm always reminded by the challenge of getting code to work at speed. And I remember reading that the latest processor that's inside the Z14 runs at like 5.2 gigahertz. And, it struck me, this is like twice the speed of a machine that I'm used to. It runs about 2.4 to 2.6 gigahertz on x86. And I'm not going to poo-poo the x86 as a great platform, but it's just that when you think about the clock speed and caching and some of the challenges around how to get your code to behave well in that space. And I also, there were two other things I was going to call out. I remember seeing there was like 640 dedicated I/O processors. I'd love you to give us some insight on what that actually means. And then the thing that really blew my mind was 32 terabytes of RAM. And, I looked at it for a second and thought, oh, is that a typo? And it's like, no, it's actually 32 terabytes of RAM. When we think about the platform itself underpinning this from the hardware and what you've had to deal with re-engineering and the whole redesign of what's become Emperor II from LinuxONE, I'd love to get some insight on what it actually means to deal with a 5.2 gigahertz CPU with 640 I/O processors, and specifically what those I/O processors do, and dealing with the challenge of coping with 32 terabytes of memory, which is orders of magnitude beyond some of the other platforms that are trying to scale Linux to. What does it even look like around that whole scale size challenge?
Yeah, well, I mean, the design point here is really around a scalable, secure data serving environment, and so a lot of that that engineering that you're mentioning here is really attuned to enabling that scalable data serving solution, right? Having the 640 power cores that do nothing but I/O means that your general purpose processors don't have to deal with I/O. That it can be completely offloaded to these special purpose accelerators that do nothing but I/O, and that way you can have a consistent, high performance, high throughput, high bandwidth I/O capability, right? Which is really, really important when you're trying to serve data, to serve data very effectively, efficiently, and in a very predictable manner. Similarly, when you look at the 32 terabytes of real memory, right? What we're dealing with here is the reality of keeping data in memory so that we can get to it fast. What we're dealing with is the ability to swap workload in and out very quickly in a highly virtualized environment. And then, of course, the thread speed is incredibly important when you think about any type of locking scenario where, the faster you can get in and out of locks, the less likely you are to see those locks contended. And so for scalable data serving environments, that single thread performance, speed is just incredibly important to be able to provide truly scalable workload. I mean, another key point to take away from the system design is that it also has some of the largest caches in the industry. In fact, the fourth level cache is 670 megs. There's just nothing like that in the industry elsewhere. So it is really all about that having a design point that's really amenable to scalable, high performance data serving.
Yeah, I think when we each of those things we could have a whole hour discussion on their own right, but I think this is where the people say legacy with a negative connotation, but I never allow that to happen. I mean, legacy is a very positive thing in my mind. But these are not engineering challenges that everybody's capable of dealing with, in my mind. And when we think about that whole speed and scalability, organizations sitting in their boardrooms with whiteboard markers trying to perform Jedi mind tricks around their design patterns fall over constantly when they try to scale from sort of 1 to 2 to 16 to 32 to 100 to 200 to 1,000 instances of anything. And yet, what I'm hearing here is this is something you take for granted. And I think often it's one of the world's best kept secrets that by default, a platform like this comes with this capability, and it's an assumed that you can scale to that size. I'd love to just quickly delve into the inside of the I/O processor component. I mean, there's 640 dedicated I/O processors. I suspect that most people listening haven't really understood what an I/O processor means on a platform like this. Can you share some insight into what it actually means to even have that baked into the platform?
It means that your general purpose processors can focus on doing general purpose work, and they can offload any I/O processing to these dedicated processors, and the I/O can then perform in parallel. It can be driven, it can happen without having to disrupt the general purpose work.
Right.
And so you can get in and out of your disks and without having to disrupt the actual workload. Yeah.
And it's when we think about kids getting into design and coding these days, it's something that they don't always fully appreciate, that when they write code, as you said before, like blocking and blocked I/O and so forth, your code only runs fast if it can get in and out of the processor and in and out of memory and actually execute and perform instructions. And so when you think about an architecture where that's got dedicated I/O processors, hardware that's dedicated making sure that data gets from one point to another quickly, it completely changes the game in my mind, because every microsecond, every millisecond that your code is sitting there waiting to do something or waiting for data to get in and out of the CPU, it's basically doing nothing but waiting. And it's that waiting that kills us, right? It's that little spinning dial on screen. The other interesting thing that I remember reading an article a while back, and I forget whose name it was, but one of the primary maintainers of the Linux kernel, it wasn't Linus, but it was somebody else, commented that when they get code back from IBM, it's invariably the case that the code's better. They haven't just ported it to a new platform, they've actually improved it. And one of the comments they made was that the speed and the scale at which IBM's platforms move mean that you have to kind of refactor the code in many ways to get it to get that performance. And when you hand the code back and you check it in and it gets reviewed for inclusion for the next version of a kernel build, that invariably this person said, and it was like the second or third most important maintainer on the planet, so I should be able to remember their name, but I apologize, I can't. But their comment was that invariably when code comes back from IBM, it's better. And it really struck me that, again, this is another sort of takeaway that people don't often realize, that you're not just porting the likes of the Linux kernel and creating the LinuxONE platform, but you're adding significant value to that in a design and engineering point of view, right?
Oh yeah, absolutely. It's adding scalability, but it's also adding first failure data capture, for instance, because we have this high availability design point, right? So it's certainly, there's certainly a lot that we do to not just port, but to enhance and provide and bring a lot of these sort of design characteristics to that Linux environment. Absolutely.
And I can imagine the sitting in the room looking at the code coming back and just expecting to be ported. All of a sudden you sit there and go, oh wow, this is a whole piece of refactored code. What happened here? It must be an interesting experience for them to get it back and actually get it in a good form, because I know from having been involved in various port processes, particularly BSD 4.4 Tahoe moving to another platform inside Hewlett-Packard and Prime back in the day, which ages me. Our challenge was to just port the OS and get it working, and we didn't have the ability to play with performance tuning. It must be nice to be able to have a design team that has the ability to actually have that capability to work on performance and scale and actually make it work and then hand it back. That's probably pretty rewarding. I'd love to get into the detail of where encryption and security fits in here. I was doing some math on this the other day, and I've got some research I do myself in this space around data breaches and some of those incidents. And there's an average of 1,400 data breach incidences a day. Now, they're not all the Equifaxes and the Yahoos and the LinkedIns, but and I'm not picking on them for any reason. They're just some big ones. But we're not talking about hundreds of millions or dozens. I mean, a lot of the 1,400 daily incidences of data breaches are hundreds, if not thousands, of records. But they're invariably getting more and more critical. They're not just geeks talking on a web forum anymore. They're general practitioners. Yesterday, there's one where a medical practitioner had their website broken, and they, for some reason, decided to keep the database of their clients on their web-based platform. And in my personal life, my son had an account on a platform called Edmodo, which is kind of like a Facebook for kids in the education space, and something like 79 million accounts got breached. So it wasn't just usernames and passwords; it was the entire dump. So every comment that my then 12-year-old son had made in this platform, and he asked me a specific question. He said, "Dad, have they read everything?" And what he was concerned with is he'd made these really cute comments backwards and forwards with a friend who was a girl in the class, and he was worried that people were going to see it and tease him. My wife had her data breached in an incident here where a blood donation website that's run where you can register and go to a hospital and contribute blood to various things. They ask you a whole bunch of very personal questions around sexual history and preference and blood type and other things like that. And it was breached in totality as well. And so, I've personally been touched by this stuff. I've been in a data breach. I've been in every modern data breach of, my LinkedIn account's been broken 3 times. Not just hacked, but my data's been breached 3 times. And it's like Xbox, and you could list these things off. So, Yahoo and Twitter and PayPal and eBay and the list goes on. I've personally had my data breached. I'd love to learn a bit more about the thinking that went into sitting back and saying, well, if we're going to put data in containers, so we're going to do it in a cloud format. Where do we start as far as a clean piece of paper goes, and how do you design that architecturally into the likes of secure containers and the platform itself and pre-stored keys and protect that? Can you share some insight into that sort of approach? How you approach that from a design point of view? How the developers approach the whole concept of building security baking it into the DNA?
Sure. I mean, for us, it was key to leverage the hypervisor technology that we have. We have this really unique nested hypervisor technology that allows us to put 85 different hypervisor instances on a single box, and those are basically LPARs, and then of course each of those hypervisors then can run a SKU of Linux guests. And so we had a really good sort of starting point with that capability, right? Where, because you now have this concept of hypervisors built into the hardware of the system that can host software-based hypervisors, you have a design point where you can insert security and trust that other systems don't have. And so with that, and through some clever design and leveraging, a lot of investment that we've put into our hardware around crypto performance, with the Emperor II, the crypto performance is 4x better than other platforms. By leveraging that and the fact that we have an integrated system, we were able to do things that other systems that are much more piecemeal in nature and don't have that ability to fully integrate. Well, we've been able to do things that they just can't do, and that's why we have these the ability to do these secure containers that are really encapsulating of entire stacks and protect and encrypt and create these completely private environments, and so that we had good DNA, as you point out, to start off with, and that really gave us the right lever to build the secure service container technology.
And I remember reading the release that came to me. It scales out now to something like 2 million containers. Is that right?
Yeah. So we talked a bit about some of the vertical and the scale up and the scale out capabilities, and to drive that point home, we decided to do an experiment where we wanted to pack as many Docker containers on a single box as we could. And so we got up to 2 million, and we could have kept going, frankly, but we figured 2 million was probably a good place to stop.
That's just showing off.
Yeah.
Well, I mean, realistically, I guess when people think about scaling that level, there's a term that IBM uses called diagonal scale, and when you talk about 2 million containers, it's a number with 6 zeros behind it. It's probably 2 or 3 orders of magnitude beyond. I mean, I remember seeing an experiment come out of the US. I forget which university, but they played with, I think it was up to 10,000 instances of a container in a public cloud, and there was cheering and clapping and high fives. I can imagine sitting there just looking, thinking, "Wait, dude, we just did 2 million." When you think about diagonal scale, though, I'd love to get your thoughts around when you do that and you roll it out and you say you could have gone past 2 million. I mean, where does it go? Where does it end? Does it end? I mean, when you talk about diagonal scale and you keep bolting these big boxes together with this, capacity to scale on a linear basis at a cost-effective form, what does diagonal scale mean when it comes to scaling something like LinuxONE?
So diagonal scale is about scaling up, but it's also about scaling up and being able to sort of leverage the combined capability of scale up and scale out in a single system, and that actually has some very neat and powerful value in the in the context of microservice architectures. But to sort of just to complement the 2 million Docker containers for scaling out, I mean, we did another experiment where we decided to scale up a single instance of MongoDB. And so we got to set a single instance of Mongo that was 17 terabytes. It's 17 terabyte database running with 16 terabytes of real memory behind it, and that kind of illustrates the opposite effect, where instead of adding more more containers or more guests or more transaction execution environments or application servers, what we really wanted to do was scale a single database so that we could grow that database as the demand on it grew, and so it really is quite novel and elegant to be able to take that combined growing of a single image, which is particularly valuable when you're doing data serving, and you're doing data serving where you need a single point of truth, and then combine that with your ability to sort of scale out all these applications that tap into that database, and to do that again with a really efficient communication protocol where things are essentially moving around in memory instead of over a network, and that does create some interesting and powerful capabilities for getting at your data effectively, and then doing much more with that data once you get your hands on it. Because if you think about it, the time you spend going over the wire to get your data is time that you cannot spend then doing analytics or insights or gaining insights into that data, because typically you're working with a fixed service level agreement that requires that you respond within a fixed amount of time. If you spend a lot of that time just moving data, you're not spending good time. You're not investing that time effectively in understanding the data. And so we've had customers who've done who've moved their analytics workloads from an Intel cluster sitting beside their LinuxONE environment onto the LinuxONE environment, and seen 5x improvement in data latency, and the ability to reinvest that time into insights and analytics was, to them, their language was, this opens the aperture on innovation for us.
Right.
So yeah, I think it is really novel and elegant what you can do with this type of topology.
Well, I think when you were talking about latency there, when we think about delays, I mean, if something's moving in and out of the chip at level 1 or 2 cache, we're talking about sort of half to 1 or 2 nanoseconds, which is hard to comprehend. When you get it to the point where it's moving around in memory, you're still talking about sort of 100 nanoseconds or so from memory. Once you get it out of there and it's starting to move across the network, you're talking about 10,000 to 20,000 nanoseconds, which is starting to really get up there, right? If you're moving a megabyte of data sort of from memory to network, you're now talking about 200 to 500 nanoseconds. By the time you get it across the floor on the network, all of a sudden you're out of the nanoseconds. You're up to sort of, I think even on SSD at the high end, you're still talking about 1 million nanoseconds. By the time you get to and from disk, it becomes 10 and 20 million, and then away it goes. And all of a sudden it goes from nanoseconds to seconds. And if you're doing 1 million transactions a second, that's 1 million seconds. That adds up pretty fast. And I don't think that many people sit there and do that math, but the transition from each of those layers, and you end up with 1 to 2 to 100 to 1,000 to 1 million nanoseconds. They become seconds. Every second counts when you scale it up. What did the performance look like when you scaled up? I mean, when people think about databases and data moving around, it's hard to visualize it. Can you maybe just give some context to what it means to have 17 terabytes of data that's in a single image versus 17 servers with a terabyte each sitting on a network? I mean, there's some design. I mean, there's a million different design benefits, but I mean, you can have your code sitting in one place, your data sitting in the same place. It can be moving in and out of the same piece of memory in the same CPU. What are the sorts of aha or eureka moments that you see people from your customer base have when you sit there and you talk about this, and all of a sudden they realize that they're not having to engineer the platform performance issues anymore? They can now worry about the code and the data.
That's exactly it. When you take the challenges of having to manage the data and make it accessible to meet the needs of their service level agreements, you take that out of the challenges that they have to deal with, and you're letting them really focus on their core competencies and in turn, create a much richer experience ultimately for their end users and their clients, and that's value for them. That's a competitive advantage for them ultimately. When we talk about scaling up the Mongo database to 17 terabytes, I mean, we're talking about read-write performances of under 4 milliseconds, and the minute you have to start partitioning that database, you're looking at an order of magnitude of latency that you're adding in easily, right, to that story. So it makes a big difference. And that latency really does turn into business value, because you're now able to spend more time understanding the data than moving it. You're also going to get a much more secure environment, because you don't have to worry about the data moving across a network, and then the network has to be secured, and so on and so on. You get a more robust system because the less moving parts, right? Less moving parts means essentially better resilience, better availability, more robustness. So there are lots of good reasons to want to scale up, and sort of remove the need of having to engineer these systems to address all those concerns now in a manner that then taxes you and doesn't allow you to really invest in your solution as much as you might have liked to.
I always get these people say to me, "Oh, there's such a sticker shock when you talk about some of this big iron," and then I like to get a piece of paper or a whiteboard marker and a whiteboard and start adding up. So, hang on a second. If you think about it in transport and logistics, do you want a fleet of 42-foot containers moving around on the back of purpose-built trucks that you don't have to think about? So you put something in a package, you put it in a post office, it goes from one point to another, and they take care of the logistics and transport. Or do you want to buy a fleet of Uber cars and move little pizza boxes around yourself, if you'll pardon the pun? And when you start adding up all those design challenges and all the engineering challenges, to be able to just jump to a platform where the hardware's capable and the Linux platform is capable, and the scale at which you're talking is sometimes I think it's beyond the comprehension of most developers and most engineering houses, particularly at enterprise level, because they haven't been used to that scale. Or alternatively, do you invest in the right platform and spend your money up front on something that's already been engineered to be appropriately scaled and speedy and sizable, and just focus on the core business at hand? What's your business challenge? What are your enterprise challenges? What do you as an organization need to do? And it's interesting, I get these people sit there and go, "Oh, okay, I hadn't thought about it like that." So when you don't have to worry about stacking up hundreds, if not thousands, of little machines, and you don't have to worry about a network then that can move data fast. You don't have to worry about the security and the routers and the switches and the servers and the RAID arrays and the SAN and the NAS and cabling and God knows what. When it's all in one platform, and you can assume then that that's there, it's interesting to watch them sit there and go, oh, okay, well, I could spend lots of money doing all these little interesting pieces where there's lots of moving parts and lots of risk, or I can move to a platform that just assumes that that's baked in. And the change in thinking is interesting. Are you seeing, not so much the eureka moment, but are you seeing a shift where people now are realizing that they can get access to a platform where they thought, oh, we're a Linux shop, we can't go mainframe. Oh, okay, well, tick, that's a solved problem. We're a MongoDB shop, or we're a Spark analytics shop, or we want to run HDFS and Hadoop. And all of a sudden you say, well, these things run native. So what's your next question? Oh, okay, so it runs natively on Linux, yes, and you run Linux natively, yes. How does that conversation look when you're sitting in a room with someone who's putting all these blockers up and all of a sudden, well, that's no longer an issue, that's no longer an issue. So you start to delve into what is the challenge? What kind of things come out of those conversations in your experience? Because, I mean, you're at the bleeding edge of it, you're at the coalface. Where do people lead to and quickly sort of get the point, well, if we take all those blockers away and those assumptions that were all wrong, what do those conversations look like in those rooms when people start to focus on what their core business is and how they can leverage these strengths of the platform?
I think, you know, it's always nice to see that eureka moment where people go, wait, we can do this. You know, I think there's always challenge in sort of overcoming some of the religion that exists that you mentioned as well around this attachment to legacy, and it does take work to kind of get some people past that sometimes. But what's nice is when you can talk to people who don't have the burden of that religion or that bias, and they see the value, and their eyes light up and say, "What? You can do that?"
I'd love to be a fly on the
amazing.
wall in those meetings.
I mean, I really love. We've been partnering or working with Plastics Bank. I don't know if you know who they are, but they're basically developing a system to recuperate plastic waste from the environment and build an economy around that. So they're using blockchain technology to build a currency and a whole economy around recycling plastic. So
Right.
So they're on one hand helping the environment, but they're also sort of addressing poverty in a lot of these countries where there's a lot of plastic waste. And
Yeah.
they have this very grand goal of going from no users to like 1 billion users in a year. Okay.
1 billion.
And 1 billion.
Wow.
And you can imagine that they don't want to have to stop and re-engineer their infrastructure, as they grow exponentially, right? As they scale exponentially. And so they picked LinuxONE, right, as the system to back this for them.
Right.
And that's because they can get the trust and the security, but they also get the non-disruptive scale up that they need to ensure, right, that they can grow at the rate that they need to grow. So
And
yeah,
I think-
I love that. I love what they're doing.
They're the kinds of things that I think people, I try to avoid being an evangelist because people, as you said, they start to get that religion experience. But I think there's a lot of learning for people who have not necessarily realized there's other options, and so they have defaulted to the traditional spaces of, I'm going to throw it up in the public cloud, or whatever the case may be, or I'm going to try and create my own cluster of hypervisors. And yet, when that anecdote you were just sharing there around the plastic bank, I mean, I think we're going to see a Cambrian explosion, if you'll pardon the phrase, of new smart ideas realizing that they don't have to reinvent the wheel. They've just got to decide which kind of wheel they want. Because the scale of when you think about the population of the planet and you take an idea and you apply it to it, it's easy to get lost in the Western view that there's hundreds of millions of users. But when you do the math, and there's 1.1 billion people in Africa, there's 1.3 billion people in India, and 1.4 billion people in China, just those 3 continental regions or 3 nations nation groups, if you group Africa together, that's 3.8 billion people. So if you solve one problem for each of them, you've got to have, as you said before, like 1 billion new users. And the scale and design challenge that comes with that isn't something that many other platforms can cope. So it was interesting to hear you mention 1 billion new users, right? Because I think that's the kind of thing when we were talking about humanities earlier, when we think about music and art and health and aviation and automotive and food and logistics and retail and transport, the day-to-day things that we count on, they scale very quickly now when the likes of an Uber comes along and someone just changes or transforms something. You have immediately got to scale up. You've got to get to 1 billion people quickly. I'm interested, actually, and we're coming up into the hour, so I'd love to just throw some things at you. This one in particular, I love to sort of get some insights into what some of my guests who have unique positions of view in many ways, and you're certainly well and truly in that position, as to what's coming up over the next 12 to 18 months and beyond. Given that you're one of a small group of people around the world who are inside the sort of the workshops of these spaces, if you like, where are we going to be in the next 12 to 18 months? I mean, what do you see coming over the horizon as far as not just LinuxONE and the IBM platform, but the big shifts? So, as you enable the plastic bank type projects, I mean, you've got this unique view of what's possible. I mean, where do you personally think, above and beyond the whole IBM view of the world, where do you personally think things are going to go now that LinuxONE's available, not just the Emperor II, but the whole platform as a whole, with the baked-in sort of, benefits of all of the 50-plus years of heritage and the assumed security and the speed and scale we're talking about here? What's possible in the next year and a half or so? What does it look like in your mind?
I think we're headed for a second wave of cloud-enabled applications, and I think a lot of that's going to be based on what I refer to as confidential cloud computing. I think with confidential cloud computing, where you can put something in the cloud and you can trust that it is completely secure and completely private, and even under federal warrant, the cloud provider could never get access to that data. They'd have to send the FBI to the actual tenant or cloud user to get access to the data. I think that today is we're seeing that with obviously with the IBM cloud and with now with Azure as well. I think that is going to become the de facto standard for cloud computing, and with that, I think we're going to see a whole new wave and generation of cloud-enabled applications make their way to cloud, and I think you throw in the what we talked about with the data, the rise of data breaches in the industry, but the pressures of being agile and being able to leverage cloud as a means for scaling up quickly and going to market quickly. I think there's going to be a lot of pressure to make sure that those environments are confidential ultimately, and I think that's going to become the standard for how we do cloud computing very, very quickly.
It's a great insight, actually. It's on par with a number of things that I've been witnessing myself. And there's over the years we've had the likes of when we think about security and the frameworks and so forth, that and some of the governance around the world. There's been the EU-US data shield in place for some time now. I don't know that many people have even been familiar with that, but essentially it's a framework and an agreement between the US or North America in general and Europe. And then there were modifications to that. So Switzerland and Denmark and Norway and others had their own sort of, Swiss EU-US data shield sort of adjustment to it to suit their purposes. But we've got some very big things coming through. I mean, early next year, I think is it March 28th from memory, the European Union are going to actually put some teeth on something called the GDPR, the General Data Protection Regulation, where a lot of the current platforms and incumbents, if you like, in the public-private hybrid cloud space are not going to be ready and capable of meeting the GDPR requirements, and the risk of not being ready or not complying fairly dire. And I like to term those Y2K moments, because when you get to early next year and this becomes law, I think it's like 20 plus million per incident, or 4% of your revenue annually per incident. So if you have a million records vanish for whatever reason, it's a million, 4 million times 4% of your revenue. It's such a Cambrian explosion of risk for organizations that they're not going to be able to afford to go and put things in places where they can't just be guaranteed in black and white writing contractually that, yes, we can meet FIPS 140, yes, we can meet GDPR, yes, we can. Russia shut down LinkedIn because they couldn't be guaranteed that Russian nationals' data signing up to LinkedIn could stay in the country. So they just shut the platform down. We've seen China a couple of days ago shut down the WhatsApp platform. Now, there was a whole bunch of debate on why that happened, but the bulk of it to me seems to be because they were concerned about Chinese national data leaving the country. In Australia, for example, businesses, and particularly public sector network organizations, can't put data in the cloud of a certain type because we have data sovereignty challenges. Now, when you think about supply chain, when you think about somebody that's in the US supplying to Asia and India and Africa and Australia, and the data moving with that, GDPR hits you, the EU-US data shield comes into play, then there's the nuances across Switzerland and other nations have got their tweak on that framework. In Australia, you've got the Privacy Act that goes back to as early as 1918. We've now got a Notifiable Breaches Act that's just come out this year in January, where if there's any incident that looks like a breach, you have to notify the public so they can make informed decisions about it. And I think we get the point now where all the things you're talking about there, that the over the horizon's probably not quite that far away, where there's some specific Y2K moments coming up that are going to impact us. There's one, I think it's February next year, the FAA in the US has deemed that every airplane needs to be at the same level of BIOS of I think it was the Boeing 787 with data capture and logging. So these are big things that are coming about where organizations can't afford the time and effort to build it themselves. They're going to have to be able to just go and buy it off the shelf, if you like. So I think you're absolutely smack on the point there that over the horizon, this big shift to the assumption of security, the assumption of protection, the assumption of scale is going to be in need. Are there examples that you've already seen people adopt this already before we wrap up and get to the top of the hour? Are there any anecdote examples of people, and you mentioned the plastic bank, do you see organizations already coming to you with this sort of clarity, knowing these things are coming through, saying, hey, look, we realize that we can't get this in other platforms. It appears you've got the only platform or the leading platform on it. Are there any, without maybe even naming the brands, that you could sort of share some insight into that folk listening could look at it and say, well, that applies to me. I think that's something I need to do.
Well, I think we've, with the IBM blockchain solution in the IBM cloud, which is hosted on LinuxONE and leverages that secure service container technology to ensure privacy and protection. I think we've seen that capability, that guarantee has really helped differentiate the IBM blockchain solution. And, we've seen a really good story and a lot of good buy-in and onboarding of new customers. And I think a lot of them have been in the press. So I think that's a great proof point for, there's a need for this and people value it. And if we can extend that capability into a broader set of use cases, and people are already asking, can you do more than just blockchain with these secure service containers? Can we put a database in there, for instance? Can we put our transaction processing environment in there? So yeah, we've definitely seen a lot of interest, and like you said, I think there's a lot of market pressures that are driving that need. So yeah, I think it's inevitable.
Well, I think it's an exciting time for us because we're at the point now where we've got things that are impacting us that we've either got to stop happening because people have made bad decisions on design, or they've had time pressures or cost challenges where they just haven't been able to invest in the security. I think we're in an exciting time now where, for me, I think we've got this situation now where you're enabling this whole next generation of applications and next generation of service level, where, as you said before, having a platform put into the cloud, whether it's on-premise cloud or hybrid public cloud, where we can assume that things are secure. And as you said, without somebody with a gun rocking up your front door and a warrant and demanding you hand over the password or your keys, providers can put their hands. We saw the thing with Apple and the iPhone and not wanting to decrypt data. I don't think it's the provider's role to do that. I think we need to put control of the data back into individuals' hands, both as consumers as well as service providers offering the actual platform. So I think you're absolutely right. There's a whole new generation of thinking and design around next generation apps, next generation security, and also speed, time to market. So look, thank you so much for your time, Marcel. So Marcel Mitran, you're the CTO of IBM LinuxONE. You're a distinguished engineer at IBM Systems. You've had, as we saw, 20 years of developing both hardware and software, so you've got a very unique view of the world. 16 exciting years at IBM, and particularly focused of late on Linux and LinuxONE, and the recent announcement of Emperor II. Thanks for sharing that with us. Some amazing insights there. Thank you so much for making your time available. It's been an absolute pleasure talking to you.
Well, thanks for having me, Des. It's been fun.
And hopefully we'll have you back on again soon. So, folks, we're going to wrap up there. Some amazing insights, and I'm sure you've enjoyed them all, talking around security and speed and scalability of Emperor II and the LinuxONE platform. And that, we're going to wrap up, and thanks for listening. Cheers. It's Des here, and Marcel, thanks so much for your time.
Thanks.